Okay, so let's just quickly go through very, very basic. Okay, that means you have to know what the definition for the cycle. Okay, and the frequency period. Okay, and also when you see the sine wave displaying on the oscilloscope, you're able to identify what the V peak or V peak to peak or VIM is. Also, the period and the frequency. That is just a very, very basic. We must get through it. Last time we already talking about the diode. When you're working with a diode, then you must know is it a diode on conducting or diode off. That means they're not conducting. And if they on, what happened? Okay? If they off, what happened? We already done that. And therefore, you guys, to make sure, review it, normally you get an idea. Diode, that means the voltage across the diode will be 0. Okay? And also they showed you when they reverse bias, that's not conducting. Look like they open, no current can be flowing. And it forwards. Bias, that means they on. Current for able to flowing from anode to the cathode. And also the difference between the ideal will be a second approximation that normally, okay? So the diode, when they on, you be substitute the diode by 0.7 volt for silicon diode or 0.3 volt for germanium. However, we must deal with the silicon diode. And also if they open, that means no current flow. That one we already done. Now, today, start with that one. Zener diode. Okay? And when you see the symbol here, okay, that will be a Zener. Okay, now the Zener diode will be look like here. Okay, positive here, this is a positive, and this is a negative. Okay, and normally they say a major application for Zener diode is the type of voltage regulator for providing stable reference voltage for use in a power supply, a voltmeter, and other instruments. Normally, the Zener diode, when you go to buy the Zener diode, you must be telling them what voltage you want. For example, I say I want to buy a Zener diode with a VG equal 5 volt, 10 volt, or whatever voltage. But they must identify the voltage. Otherwise, they don't know how to do. Okay? And also, Zener diode can be working like normal diode. If they're working in a normal diode, then this side will be positive and this side will be negative. And same thing, okay? They will be 0.7 volt for silicon diode. This is the first one, introduction into the Zener. When you're looking into the Zener, you're able to recognize, okay, this is Zener diode. And when they break down, this side will be positive. This side will be negative, okay? So you can see This is a cathode and this is a anode, but when they break it down, this side must be positive and this side must be negative. Okay, if you get any question, anything confusing, just bring it up. Now, for this circuitry here, you get a zener here. When you're working with the zener, you get three things to be happen. Okay? First thing is the zener breakdown. Second thing, they can be normal, working like normal diode. Okay? And now they will be not break down. And also not normal. Okay? They have to be either one. Now, in this case here, the zener diode voltage, they given to you 10 volt. Okay? So that's only telling you any voltage at this point higher than 10 volt, they try to bring it out. Only thing you can get will be 10 volt. That's why they're using in most of the power supply. Power supply, they say you get 5 volt. So we want guarantee the output of the power supply have to be 5 volt. So that's why they put a zener diode with the VG equal 5. No matter what, if more than 5, they can be break it down to 5 volt only. Okay? So now, for this example here, what happened to the zener? Breakdown or not?
Break it down.
Yes.
Break it down.
Let's break it down.
The thing is you get a 20 volt right here. That's higher than 10. So zener will be breakdown. And the VL supposed to be equal 10 volt, right? This the answer will be VL equal 10 volt. The thing is zener breakdown. That's number A. You get that? And now they will be asking you what is the current flow here. Telling me what I equal.
45.5 milliamps.
Okay? The voltage across the resistor will be the difference between 20 volt and 10 volt. Right?
Yeah.
So they will be equal 20 minus 10 and divide to 220. No matter what you get, okay? I just show you how to do the calculation. Okay, any question up to this point? And that will be B. That will be A. No question, right? So,
Since this thing, okay, real quick.
yeah,
So since this can only allow 10 volts, you have to subtract it from the original power source, and that's how we're getting 10. Because it,
VG equal 10 volt.
yeah,
Okay. Then what happened? If you get input 20 volt,
it's gonna go boom.
right?
Yeah,
That's higher than 10.
yes,
So diode, will be breakdown. When they break down, that means I already gave it to you. You get 10 volt here.
yes.
No matter what, something else. Is it right? So that's why you get 10 volt, and if you want to current, you can get a 20 volt minus 10 divided to the 20.
Okay.
Okay?
Fran. Mr. Fran.
Yeah.
So the Zener diode has the ability to be in a component that could be made for adjustable voltage gate.
That doesn't matter. Only thing is, they want to keep a certain voltage be designed already. That's why I said, when you want to buy the Zener, you have to say 10 volt, 5.1 volt, 5 volt, whatever voltage. And the power here, they can be any power, doesn't matter. But if they higher than 10 in this case, then the Zener will be breakdown.
What does the number letter and number next to the Zener diode mean?
This here,
Yes.
just the part number.
Okay.
Hey, Mr. Pham,
Yes, sir.
if you flip that diode upside down, is it like just reverse bias, and what happens then?
I don't know. We'll see.
Okay, surprise, huh?
That's what I try to say, is how much people understand. Now, they say, I can that, not 10, I can do 5 volt. Okay, and they want to know what is the V out here.
5 volt.
5 volts.
You understand, right? Now, in this case, telling me what happened to the Zener. They break down or not break down, or they are normal.
Reverse
It's a-
bias,
Is
but not.
is acting like a normal diode?
Now,
It is open.
yeah, they will be not break down, right?
Right.
They will be not normal. Why I said they not normal? If you get a file here, they cannot be open. They cannot be normal working.
Okay, yeah, that's right.
Okay, so in this case, they will be open,
Open.
right?
Right.
You see 5 volt here, then that will be open. Open means nothing here. Okay? So the circuitry now will be open circuitry. So V out will be 5 volt. And if they can asking you, what is the current here? Tell me quickly.
0.
Perfect.
0. Yeah.
Perfect. They 0.
And
The thing is open circuit. Okay? And also they can asking you what VR.
Zero.
Perfect. VR mean equal I times R. And I equal 0. You time anything, they can be 0. That is how it goes. Also, for this type of the circuitry, you have to know right away. Don't have to do much calculation, okay? They may guarantee you understand. Okay, any question up to this point?
I have a question. If you replace that diode with a normal diode and with 5 volts, you'd have the same result. So I don't understand why you're saying it's not normal.
Not normal, that means, they're not open, they're not working.
Well, it would be, it's reverse biased, right, with 5 volts?
No, they're not biased. They're not on.
Yeah, it's reverse bias, so it's off, like a normal diode would be, right?
Not the diode there. That means I want to tell you the diode will be open.
Yes.
Okay. Now, one more thing. Guarantee we can get hit into any situation. I can that one. Okay. To minus 10 volt. What we out?
0.7.
642.6 milliamps. Millivolts, excuse me.
What the V out?
642.6 millivolts. 42.5 milliamps.
Come on.
Hey, Mr. Pham,
Volts.
Yes,
Would-
sir.
Minus,
would-
that's
would this-
negative. That's negative.
Minus 10.
Minus 10.
Minus 10 was, yeah, it's the same as the last one, pretty much, right?
Minus
It's
0.6.
just that you have a smaller voltage.
It's normal diet.
Yeah,
0.7.
yeah, 0.7, yeah, 0.7. Correct.
Okay, tell me now.
It's going to be minus 0.7.
You get minus 10
Oh.
from here, right?
No.
No. No.
Okay. So the signal now working like normal. The thing is this will be a 0. And minus 10. Diode will be on. You see that? The
No.
diode will be
Yeah.
on. Normal.
Normal. Yeah.
Because, Mr. Pham, you're saying because 0 is a bigger number than minus 10.
See, for sure, man. 0 must be higher than minus 10.
But the diode can't support a forward voltage of 10 volts. It's going to limit out its 0.7, right?
Now, when the diode on normal, I want you to substitute diode by the battery. So this side will be positive. This side will be negative. Negative, positive, the value 0.7. Okay, so the output, they will be equal minus, that is the answer.
My simulation doesn't show negative 10 there above the diode. It's all like negative 642 millivolts.
It's not minus
Okay,
10.
minus 0.6, 0.5, 0.7. That be fine. When you measure VO across the battery, you get that battery.
I think the 10 minus 10 volts shows what the voltage would be if the diode wasn't there, right?
You say minus 10 volt? 10 volt.
If you remove the diode, then the output voltage would be minus 10 volts, right?
If you remove,
If I remove the diode from my simulation, it equals 0 volts. They're at after 220, to the right of the resistor.
if you run the simulation, you get a V of the diode is 0 volt. That
Right.
means you need to know how to set up your oscilloscope to display, AC coupling or DC coupling.
Could you write out that equation?
What equation?
How you arrived at the
In here, we don't have any equation, right? The reason is, I say right now I get minus 10 volt here, right? That will be telling you, you're supposed to get minus 10 volt here. And the first thing I can be telling you, the zener cannot be break down.
Oh, that's right, minus.
They only break down if the voltage higher than 10. Now, they not break down. However, you get one side diode minus 10, the other side 0 volt. So diode just working like normal. That's what I showed you right here. This right here. They just working like normal. When they on, that will be positive here, negative here, and the value will be 0.7.
Mr. Pham,
Yeah,
so for example, if we take off the negative sign out, the answer should be 9.3. If there's no negative at the voltage,
no.
if it's 10 only, if the voltage is 10, the answer should be 9.3.
No, depend. You get a diode here. So if you get a minus 10 here and a 0 here, the diode have to be on normal. The thing is the voltage between the anode and the cathode difference will be higher than 0.7. So they will be on. When they on, then this side you put a negative, this side you put a positive, substitute for this guy. Now you can get only power supply 0.7 volt with a negative here and a positive here. So when you measure the V out here, you're supposed to get a minus, and that will be 0.7.
Right.
Okay. Any more questions? Make sure it's clear for everyone from the basic. So when they go into a little more complicated, you're able to understand. Now, you do it from me to see how many people can get through it. First thing they want to say, they want to take it out first. No load. They want IL, IG, V out. See how many people can get the right answer. Either take one or take two doesn't matter to me. Only thing is when you see this one, you know right away how to get it. That means perfect to me.
Well, the source voltage is well above the zenith voltage, so the diode would be in breakdown. You know, we-
Now, the first thing, no load condition. A, what IL equal?
It's going to be 12 volts.
It's gonna be
divided by
12.
divided by 490.
The
Come
load,
on.
the load current is going to be, the load current is going to be 12 volts divided by 490 ohms.
No, I say no load. That means I don't have a this one here.
Oh, you said no load. I thought you said load.
This on
Infinity.
breakdown.
Infinity
If there's no load, then there's no load current.
is infinity.
Come
So
on.
IL is 0.
It will be.
24 minus 12.
Come on. I asking current.
Infinity.
Current is 0.
0.
200 pico.
The thing is when we remove the load will be open. The current
Open.
must be 0. Right? Open. How come the current can be flowing?
Hey, Mr. Pham, so you have no load, no current, but the output on this circuit would still be 12 volts, correct?
Yes, sir.
Because it's in breakdown and the cathode side is a reverse bias and it's beyond that. You got 24 volts versus 12 volts.
Okay. So now B I G I current of the zener.
That would be 24 minus 12 divided by the resistance 470 ohms.
Yeah, perfect. Now, in this case, the zener will be breakdown, right? The thing is the 24 volt higher than 12 volt. So zener will be breakdown. And they're telling you you get 12 volt right here. And this time will be 24 volt. So easy to calculate the current will be 24 minus 12 divide to 470. Okay. And the C will be asking for V out.
B is IZ. Okay.
V out is
I
12,
see.
right?
Okay.
Mr. Pham, V out is 12, yeah,
They equal the breakdown voltage.
right.
If you're confusing, okay, go ahead and asking. Try to make it clear.
So I don't understand why the 24 volts has no role in the 12 in the answer.
When I say no load, that means I want to remove a load out of the circuitry.
Right, but I meant the 24 volts on the other side, not the part that's removed.
The 24 volt, they cannot be going to the V out. The reason is the zener be breakdown.
The reason is why?
What's the reason? When you get a 24 volt in here, they supposed to be 24 volt in here. However, the diode zener break down, so you cannot get 24 volt here.
Oh, right. Okay, I see. You subtract it from the 24 volts.
No, it's not subtract.
Oh,
They must be equal the zero voltage.
I think he's talking about the voltage drop across the resistor,
If
24
I
amp.
say in this case VG 12 volt, then they will be VO 12. However, if I change it to VG equal 5.1 volt, what V out?
5.1.
5.1, they equal the V breakdown, VG.
Hey, Mr. Pham, one thing you need to impress upon, and that is that for the Zener diode, everybody's got to remember when you go to the store and you buy the Zener diode, is rated at a certain voltage. And that's the voltage you're talking about, like 10 volts or 5 volts or whatever.
Yeah.
So when you, if it's rated at 12, then the output would be 12. If you brought it the Zener diode and it was rated at 10, the output would be 10. It has nothing to do with adding and subtracting.
No, no subtract, nothing.
okay.
Okay.
Almost like a not like a voltage regulator though.
Yeah, that's on the regulator. You can see in any power supply, they have to get a Zener diode. To guarantee the output, you want 5 volt, they must be 5. You want 12 volt, they must be 12 or 15 volt. Okay? Without the Zener, sometimes the voltage input here big up. You don't want that voltage go into this output here for the power supply. You want power supply only 12 volt, for example, or only 5 volt. When we're going down, you can see more. But what I want to make sure the guy can follow it, okay? What we're doing now.
But there's two differences. There's a voltage regulator that has a variable between like maybe 5 and 10 volts versus a Zener diode that's only set for a specific voltage, correct?
You cannot get the variable.
Right. So
If a variable, they have to get something else. Like, for the texture, for digital circuitry, the power supply apply only 5 volt. So that's why if you get apply 24 volt into the digital circuitry, you can cook on up the IC. So that's why all the time 5 volt must get the breakdown at 5 volt. More than 5, they break it down. Okay, now I want IL with the load. Okay, so D.
12 divided by 490.
They want IL. So that's easy, right? When you get a load, you still get a 12 volt in here. Zener still break down. So you get a load 490 ohm and 12 volt. So that will be 12 divide 490. That's how do we calculate the I load. Then the next one, they want E. I E.
It's equal to I total minus IL.
Perfect. I total minus IL. We already calculate the I total. I try to repeat here. I total equal 24 minus 12 volt. Divide 470. Make sure, you have to spend time to read the handout 100 times. One time you not quite follow it, next time you can get better and better. This is a very basic from the beginning for electronic. Make sure you can understand. Okay, any question on this problem here? If it's not, then we keep moving.
Okay, I have a question, and I am not quite understanding this, so if I don't explain myself properly, I apologize ahead of time. If the VIN is greater than the VZ, and you happen to just get like a 12 volt V out. My question is is it 24 minus 12 in that
Why
case?
not? Why you want 24 minus 12?
I'm just asking.
At what? At current or what?
I feel like I don't even know how to explain my question on it.
Here's a quick interpretation. You have 24 volts and you have 12 volts. The VZ equals 12 volts or the breakdown voltage of the Zener diode, correct, Mr. Fan?
Yes.
Right. So that Zener diode, if you were to go to a store, you're buying a component that is only going to allow 12 volts to flow through it. That's it. You have no power supply there at all. It's just telling you the rating of that component. So after that, that's how you try and calculate your circuit.
So it will only allow 12 volts past that diode. So V out will be 12. Because the thing, go ahead.
V out will be equal to 12 if V in higher than 12 volt.
I guess the thing that I am confused about is if VZ is 12 and VIN is 24 volts. I'm trying to figure out if it's the VN minus the VZ or if it just happens to be half the voltage. And the thing that I am confused about is, does it just happen to be half the VIN? Is that incidental?
That's just coincidence.
Okay, it's just coincidence. That's what I was trying to figure out.
Yeah.
You could
If
substitute
VZ
a
was 10 volts,
5.1
then it would
volt.
be 10 volts at
Okay.
V out.
Hey, look at it this way. VC, the Zener diode is rated at 12 volts. But let's say that VN is, let's say for instance, 11 volts. If VN is 11 volts and VC is 12 volts, the Zener diode is not in breakdown yet. And let's say, let's do another one. Let's say VN is 12 volts and the Zener diode is 12 volts. It still may not be in breakdown, but say if it gets to 13 or 14 volts, maybe it'll go into breakdown then. Do you kind of get how it's going?
Yeah, that makes more sense. I was just
Okay, now.
okay.
It looks like subtraction.
Now,
What if it was higher than 24 volts?
that's what I not agree when you try to say subtraction. Subtract what? You subtract 24 to 12, right?
But that's the interpretation of the circuit. That's why people are saying subtraction, because 12 and 12 is 24. So it's trying to decipher how the voltage and the current are flowing in the circuit.
What if
If it was a 10 volt Zener diode, then the total current would be 24 minus 10 over 470, right? So, and if it was 5.1 volts, the total current would be 24 minus 5.1 over 470. The Zener, if the applied voltage is above the Zener voltage, it acts like a voltage clamp. it clamps the voltage to its value. In this example, it clamps the voltage to 12 volts if the applied voltage is above 12 volts.
Okay, I can do it.
Hey, while Mr. Pham, hey, while Mr. Pham is doing this, what you got for the people who don't understand, what you might want to try is get on Multi-Sim 7, draw this exact same circuit, and then make.
Don't need it. What I try to say here, can you understand the Gino? That's the first step.
Mr. Pham, that's wrong.
Gino, they will be break it down. Okay? If any voltage in here higher than, in this case, 5 volts. You see that? If they higher than 5 volts, they break it down. That means they must be 5 here. I don't have to do any calculation.
What happens if the input voltage is 6 and the Zener diode is 5?
Yeah, it's still breakdown.
It might
higher
be
than
not,
5.
though. I mean, theoretically, that's what's supposed to happen, but I tried that on a Multi-Sim 7 and it went 2 volts over before it actually broke down.
Yeah, that maybe you can keep when you go into the simulation. However, now what I'm saying here, if the voltage apply here, 30 volt, what I say, you don't need to do any calculation. You're able to recognize 30 volt must be higher than 5 volt. Then the signal must be breakdown.
Correct.
And when they break down, the voltage right here must be 5.
Correct.
We not do any calculation, but try to see it. They break down or they not break down. If I say I can hit 30 volt here, 20 volt here to 3 volt, then what happened?
Not breakdown.
They not break down.
There is one exception to that. If the source voltage is above the Zener voltage, if the load resistance is low enough, then the voltage divider effect will keep the output voltage below the Zener voltage. So that's one complication.
So basically, the Zener diode is just like it's going to a fixed regulator of that voltage at that point.
Right.
Okay.
But only for voltages above the Zener voltage.
Right. So it's not broken if it's below it.
Right.
Okay.
And when you say broken, a Zener is designed to have a controlled breakdown so it doesn't damage the diode. A normal diode, if you go too far in reverse bias, it will break down and be destroyed. So this is a very different kind of thing.
Okay.
Okay, now if I say 3 volt, they not break down. What we out?
0.
3 volts.
3 volt. The thing is diode, you get a 3 volt on this side, 5 volt. Okay, ground on this side. Diode will be out, open. When they open, that means the current will be go this way. Yeah, anything confusing, just bring it up. We try to make it clear as possible. Now, for this circuitry, the first one, they get VG equal 3 volt. And they apply the sine wave, 5 volt peak or 10 volt peak to peak. And they want to know what happened at the output. So the first thing is you get a positive cycle here. Okay, so when the voltage input higher than 3, then diode have to be breakdown. So that's why you can see the Vout will be equal 3 volts for the breakdown right here.
Hey, Mr. Pham, so when we do, this is now like AC, because the other way we was using the DC battery, but now we're using like a signal generator. So when the Zener diode is 3, it always clips at the voltage that the Zener diode is rated at.
That means any voltage higher than 3, they cut it out to only 3.
Okay, so in this case,
they cut it out right here.
Okay, yeah. All right.
Okay, when you go to the negative cycle, that means this side will be negative.
First it was positive, now it's negative.
For normal.
They will be on normal, like we just did it, right? They will be positive here, negative here, 0.7. So that's why when they measure for this part here, they will be minus 0.7.
Oh, okay.
Get that?
So basically, we just got to break this down into the positive half cycle first, and then the negative half cycle second.
Right. They draw for just positive cycle and the negative cycle. Okay, you can look into the next one. They converted to Zener. That will be telling you when you get a positive on this side. Positive on this side, the Zener working normal. Normal, that means you get a battery. Positive here, negative here, and 0.7. So that's why you get 0.7 here. And on the negative, Zener breakdown. Okay, so that's why you can get minus VG for this part right here.
And that'll be a -3.
Right.
Okay.
Okay, one more for this thing. They get 2 Zener. So when the positive okay, which Zener breakdown?
That'd be D1.
Nobody breakdown.
You can see it right here. Okay, so normally you can get one Zener breakdown, the other one normal. Okay.
So what is it? D1 is not in breakdown?
Either one is forward bias.
Positive cycle or negative cycle.
Can you repeat that again, Mr. Pham? I didn't hear what you said. Which one is breaking down first, D1 or D2?
Okay, when you get the positive, okay, then look like, let's see, which one will be break it down. If you get a positive, that means the Gino D1 will be working normal,
Right.
okay,
And then D2 will be in breakdown.
breakdown. So they can be equal V of the G1 plus 0.7. And now you get a negative, then revert it, okay? When you're doing your MSIM7, then you can see that. But that's just a picture for you to say, okay? Now, on this one. First thing, if you get a 10 volt positive, okay, that means you get 10 volt here. So 10 volt here, basically, you can get the first one will be
Act like normal.
okay? That means you get 0.7. A second one, they will be breakdown, you get 5.1. Okay, 5.1 plus 0.7, that's why you get 5.8. And when you revert it, that means you get minus 10. That will be telling you, you get a round here, okay? And minus 10, so this diode will be on. And this diode will be break it down. So basically you get a 3.3 volt minus 3.3 volt minus 0.7. That's why you get minus 4. Same problem here, okay? You can find it down, okay? We need to go. Next one, LED, light emitting diode, okay? Basically, this one here, you can see that, that's the LED. They will be going to the 7 segment. They display a decimal for the human. And also they will be show you what that means for common anode and common cathode. Okay. This one is common anode. If you want the diode inside, you can see 1, 2, 3, 4, 5, 6, 7. 1, 2, let's see. 1, 2, 3, 4, 5, 6, 7. Now, in order to turn on this diode inside here, and common anode means this must be connected to 5 volt. This have to be connected to 5 volt. So if you want to turn on this diode, what logic here? What voltage?
4.7.
0. The thing is you get a 5 volt here, right? And if you want to turn on the diode, this side have to be 0 volt. When you're learning digital, then they will be a logic 0. You can see that display everywhere in the clock, okay, in your watch, they're using 7 segments. That means they're using this thing here to display the number, okay? 1, 2, 3, 4, 5, 6, or whatever number. I just give it to you for your knowledge, okay? We do nothing with that. Now, halfway rectify. What that mean for rectify or rectification? What that mean?
Change AC
Change
to
alternating
DC.
current into direct current.
Converting
AC to
AC
DC.
to DC.
DC.
That's what that mean for rectify or rectification. Now, if you're looking here, this is the AC sideways. However, when they go to the rectified circuitry, they will be coming out that one. This is a DC. Later on, you can see DC portion. Okay? DC means the current flow only one direction. So you can see right here, the positive current flow this way. 0, nothing. However, positive go this way. That current only go only one direction. So that's why they're converting to a DC. However, in this case, they call it DC portion. Okay? Now, looking into this picture here. First thing, you can get rectify here. Okay? Rectify here, when they output, they will be look like the one we just see. Okay? And now you put a filter, that means you put a capacitor. The capacitor will be charging and discharging. So if I'm looking in the output at this point right here, they show you VDC in here. However, on the top, they get this signal here. What's the name? Who knows? That's what we call ripple.
So ripple is AC writing on DC?
Exactly, on the top.
Okay.
That's like the noise. Okay? We don't want ripple. Ripple can be big or can be small, depend on capacity. The value of capacitor will be bigger, ripple will be smaller. And finally, they go to the regulator here, and also the output, they will be get the DC. They don't want any ripple.
So
And
Mr.
that's where
Pham,
you use a Zener diode.
That's a whole story for the power supply.
so Mr. Pham, question.
Yeah, AC voltage, 110 volt AC. However, on the equipment using in the house, inside they must be DC voltage. Okay? So that's why they have to converting to the DC. And they don't want any dribble. Dribble when the noise can cause the circuitry working not right.
So Mr. Pham, is it like this? We get AC that come from the outside pole and you come into the house, you plug your appliance in. And when you plug your appliance in, there's a circuit inside the appliance that changes the AC and the DC, and that's what the appliance is really working off of?
Yeah, that support you.
Okay.
Joseph, it depends on the appliance. If it's a AC motor, then it runs off of AC, but if it's got digital circuitry in it, then it must work off of
picture.
Okay, hey, thanks a lot.
Now we can go. halfway rectifier. When you're looking into the circuitry, you must understand this is a halfway rectifier. We have make no choice. Okay? Why they call a halfway rectifier? Why?
Half the way.
Because there is only one diode.
Now, when you see one diode, you know that a rectified, halfway rectified circuitry. My question is how?
Because of the VP.
They rectify only the positive, so therefore it's only half the sine wave.
Exactly. Halfway rectified. You see the sine wave, you get positive alternation, negative alternation. However, they rectify only the positive in this case. The negative not, they will be supposed to be right here. Only positive can be rectified.
So that's why they call half-wave rectifier for positive and full wave rectifier give you both?
Right now, we're talking about halfway first.
Yeah, okay.
They get lost. Halfway mean rectify means they rectify only, in this case, positive cycle.
Okay.
However, if I don't want this one, I can this one this way. Then now they will be rectified only negative. Okay? And in this case, if you want to see the frequency between input output, the frequency, the period for the input from here to here, T, and the output the same, T. So that's why they say output and input will be the same. Okay? And also now, the output they drawing for you here for the ideal diode. That means VD equal 0. However, for normal diode, for second approximation, then the voltage will be 0.7. Now, I'm trying to make it clear here for you guys. Okay, now, this right now I say normal diode. Don't want that. I want VD 0.7. Okay? So for positive input here, the diode on or off. For input positive. That means positive in here. And this will be round. The diode will be on. Right? If the diode on, I already said, you have to substitute diode by the battery, 0.7. So now I can substitute by the battery here. 0.7 positive, negative. So at the output here, you can get 2 voltage. First thing you can get the rectifier right here. However, you have to get another one will be minus 0.7. So they will be right here. So this signal, they not go up there. They can go this way. Okay. So if you want to measure the V peak of the signal, and V peak will be measured from here, 0, up to the top. That means V peak. If I say you get a V peak of 10 volt, then this one, they cannot be 10 volt. They can be what voltage?
9.3.
If I want to measure V peak in here, what voltage you think?
V2, Vn,
That's a V out.
Vn divided by 2 minus 0.7.
You will be hitting to this problem here. When you run the halfway rectifier, we're not using ideal diode. We're using normally diode 0.7 volt. And when they get a 0.7 volt, when the input positive, diode will be on. When they on, you substitute by the battery. Positive, negative, value 0.7. Then I know for sure at the output here, they get 2 signals. One will be sideways here. Another one will be minus 0.7. So that's why first thing I draw this is a minus 0.7. Okay. Then the sideways, they cannot go up to the top exactly input here. The thing is, they will be stacked from this minus 0.7 to go up here. Okay. And they going down. So they asking you calculate the V peak for the output, and I say V peak must be from 0 to the top. Okay. And if you get a 10 volt, then they cannot V peak cannot be 10. No way. The thing is you start from 0. So that's why you have to minus 0.7. 10. That's why you can get 9.3 volt. The thing is they put the signal going down. So that's why in here, they already given you the formula right here. V peak out equal V peak in minus 0.7. Next one, transformer. This is a transformer. What is a transformer? By definition,
Increase or decrease voltage.
yeah, transform one voltage to the other.
But it has to be alternating the current voltage.
Like you know, outside the street, they get 240 volt. However, when they go into your house, you get 110. So basically, somewhere they get a transformer. You going from 240 210. Okay? And
Stepping
now,
up and stepping down.
yeah, trend the VP right here, we call a primary voltage. VS here means secondary voltage. Okay? And the P, number of turn in the primary, and NS, number of turn in the secondary. Basically, they're using the wire. Okay? Try to make a transformer. How many turn of the wire? NP for primary, NS for secondary. Okay? And this is the formula. Okay? If you want to calculate the V secondary, that will be equal NS times VP divided to NP. So basically, only thing is when you need to do calculation, then you can look into the formula. Okay? So if you get a sine wave here, and you will be get a sine wave on the other side, the voltage will be bigger or smaller. I give you example. You get 110 volt here, and you get 24 volt here. Okay? Depending on ratio, NP and S. In this case, primary 110 and a secondary 24, they call a step down transformer. Okay? That means from 110 down to 24. However, if you get a 110 volt primary and a secondary, you get 240. So now we can say the step up transformer. Okay? So make sure you understand when looking into the circuit, you're able to recognize this is a transformer.
Hey, Mr. Pham, that step up, step down, that's based on the turn ratio, right?
Exactly.
Okay.
When you calculate, general, I just say, if you get 110 and second, you get 24, step it down. If you get 110 volt, you get a second, you can get 240, step up. Now, you understand dot right here, what that means?
Mr. Pham, I have a question. I have a question.
Yeah.
What about whatever the power in this primary and secondary? Are the power going to be equal, or is there any relation with the power?
Now they can be equal. If equal, that means the primary 110 and the second 110. That's it.
I'm talking about the power, not voltage, power.
Yeah, for an ideal transformer with no losses, the power is constant. The input power is equal to the output power.
Yeah, so it doesn't matter whether it's step up or step down transformer. The power in the primary is going to be same as power in the secondary. Am I right?
Exactly.
That's,
okay, thank you.
and following up on that, if the voltage ratio, if the voltage steps up, then the current steps down. And if the voltage steps down, then the current steps up, because that means constant power.
Thank you.
Now, my question is, you see two dots here, what that mean to you?
It's tapped.
What?
Can you repeat the question, please?
I said you see the two dots here. What do you understand?
Same ratio, same turns?
That's positive voltage.
Okay. If you see the dot and a dot here, only telling you input and the output will be in phase. Both going up, both going down. Okay? However, if you see the dot here and the dot here, that means inverted. Input positive, output will be negative. Okay?
Mr. Fan,
Yeah.
do you have any pictures of a real world transformer like an iron core or ferrite transformer that?
Oh, maybe the other time. This time we not concentrate on working with the transformer. So that's why. Okay? We
Okay.
need the transformer to do something else. Otherwise, you get too much thing to memorize. That's what I want.
Mr. Fan,
Yeah.
on this picture, there are not two dots. So are they going to be in phase or out of
They
phase?
will be in
Example.
phase. They don't care. They will be in phase.
Okay.
That means they try to using the transformer to doing something else. They not emphasize on that for inverting or in. Okay, we don't care. Now for this circuitry, you get a transformer. Can you tell me? Can you calculate for me the secondary voltage VP for second?
78 volts.
156 divided by 2.
Exactly.
That is 78.
You can get V second. Okay, equal 156 times 1 divide 2.
$78.
Is it 78 volt,
Yes.
right?
Yeah.
Okay, what the rectified peak output, they want VP second. There it. That's a V out. V out VP.
77.3.
Yeah, let's see. V peak out.
78 minus 0.7, that is 77.3. That's correct.
Yeah, 7, 8 volt minus 0.7. You know, you don't know, you can see here, right? We give it to you the formula right here. Okay. So if input frequency 1K, what the output frequency?
Okay.
Same.
The same.
F out equal 1 kilohertz. That's what we already said right here. Okay. F out equal F in. Okay. So what I want to make sure when you're looking into the circuitry, you must be recognize what type of the circuitry in order you can know how they work it. Now, next one, full wave rectifier. Now, hopefully you can understand a little more. Full wave rectifier, if you're looking at the input output here, so they can rectify the positive input here. And also they can rectify negative here, this part here. So that's why they call a full wave rectify. You get that?
Yes, sir.
Now, they're using the transformer. However, you get the drive right here. That's what they call a center tap transformer. If you're looking on the halfway here, see, they don't have a route right here. That's normal transformer. And this one, they get a route in the middle here. They call a center tap right here. Center tap cost a lot of money than normal. Okay? And when you get the output full way rectify, in this case, they say diode will be 0 volt, practical 0.7. And the output V peak out equal V peak minus 0.7. Now we go into the real one right here. So basically, you can get a primary V in here. Okay? So basically, at the secondary, they divide into two sideways. You see that? However, this will be equal V in divide 2. Okay? That means whatever V second here, you divide by 2. You get first sideway and divide by 2. You will get a second sideway. And if you're looking into that, you can see the difference. Difference is this positive, that will be negative. This negative, this will be positive. Okay? And they still working like full time, full wave rectifier. Now, this will be show you when the input positive, then the output will be rectified for that. Okay? And they show you how the current will be flowing. Okay? And the output will be rectified for this part here. And then when you go into the negative here, then they will be rectified a second one. That's why they get a full wave. Okay? In this case, they can draw your current will be flowing. And then finally, again, you can get a half a primary. Okay? In this case, you get a 1:1. Ratio 1:1. What that mean? Input, output,
Same.
second will be the same. Right? 1:1, the same. So that's why for the half here, they say take a V primary divide 2 minus primary divide 2. And the output will be equal V primary divide 2 minus 0.7. Okay? Depending on the diode on. And then this one is not the same. 1 to 2. That means if you get 110 volt here, and that will be times 2 divided by 1, right? So they can get the primary here and the minus primary here, not divide. That's just for you guys look into that. Complete calculation here. So basically, you can get positive for this diode on, negative for the other diode on. Okay? And the finally VP out will be equal VP second divided by 2. Okay? So we want to see for the circuit show, calculate the VP second. Only thing I want you to calculate it for me quickly. The thing is we still get a quiz to go. You get 100 volt peak, 200 peak to peak primary. What the secondary voltage?
152.
It's 49.3.
99.3. Yeah.
Now they asking the secondary. That means here. Okay.
Yeah.
Yeah.
49.3.
No, no.
No, the turns ratio is 2 to 1, so it's a factor
It's,
of 1/2. So it's
100.
99.3.
becomes 150.
50.
Is it 50?
50 on that side. And then half of 50 is 25.
Right. 15 means from here to here. And now they divide a half right here, right?
Mhm. So that's 25.
That will be 25. Okay. So we will be continuing on next meeting. However, what I would like you to do, go over on the handout up to this point. Okay. And make sure next time you can get a better understanding. Okay. So now we do it quickly 18 minutes for the quiz.
Is it 4 or 5?
5.
5.
You did not go into share screen.
Oh man. Again. Yeah. Thank you. We'll do it.
Volts. Ten minus 5.1.
If you guys all done for number 1, can let me know so I can speed it up. Otherwise, we have to wait it for 3 minutes. To me, just to take about maximum 2 minutes.
That should be solvable by inspection.
Try whatever you think they're supposed to be, write down. When you get a solution, you can see they right or wrong. That is the way to learn it.
We wanna.
You guys done?
Yeah. 5.1.
Okay, I go. minute.
What's the point of having a time limit if you want to rush past the time limit? I'm just curious.
What?
Dessert.
You know, if everyone wants to move on, I can move it on. Otherwise, let the time running.
You're gonna go over it, right, Mr. Pham?
Go over what?
Answer.
Yeah. After this one, I given you the solution. That's just for you guys to study.
I think we can move forward.
I guess my question is, if there's a 2-minute timer, is it a 2-minute timer, or like, why have a 2-minute timer if there's not 2 minutes? I am just curious. So
Make it 1 minute.
You understand my situation here. I have to quite doing different from last semester. Take me a lot of time to prepare. And that's why I don't want to change the time for each one. I don't have enough time to do it.
Next.
Night.
Thank you.
You're welcome. You have to understand that I can control the time here. Okay? Maximum will be 18 minutes. If we can do quickly, then the time will be make it shorter.
Is it 5.1?
Yeah, you understand, you can get it done quickly. I don't know. You get it right or wrong. Make sure you understand if we eat now will be negative 10, okay? Not 10. You can look into the side here. Negative, positive. You want to be a technician, this have to be no problem.
When we get a job, Mr. Pham, we got to get your cell number.
I'm working 8 hours, they're still not done yet. Not for Tech 1, also for Tech 2. You see that? I stay at home, not going anywhere for almost a year. Okay, done?
Next.
When you're ready, let me know. So nice, almost done.
Done.
Okay.
Yeah, this is moving too fast. I'm just gonna head out. By the time I do it,
That's okay.
yeah, I'm kind of tired of it. So I'll just look at this later.
Yeah, you can look into the video.
When you
Patrick, feel free to join the study group if you're not already a member. We can go over this tomorrow.
Just apply the formula. You have 169.7 and ratio 4 to 1. So basically time 1 divide 4. And if you want to be precise, you can apply the formula.
It's not clear whether the 169.7 is the peak value or the RMS value.
The peak of primary.
It's 169.7.
Yeah. If you want peak to peak, have to be multiplied by 2. At the university, they will be learn the same thing we're doing here. Only thing is, university, they want to be an engineer. So they will be concentrate more designer. That means for this circuitry, what type of the transformer you must be selected, what type of the diode. We're not designing anything. We're testing. Still one more. Yeah, 13 will be the last one. But this will be easy, right? Frequency out will be equal to the frequency in for halfway rectifier. And make sure before end of today, make sure you try to get your hand out and read over and over and over. So you done, right?
Yeah.
This is easy one. Okay, now I will be running for you the key. Okay, and try to check the answer. Okay. Okay, so that is the output will be 5.1 volt and IR1 will be 3.27 milliamp. Okay. Okay, number 3, Vout equal 4.5 volt and the current IR1.
What's the answer for number 4?
Number 4, that means IR1, 0.
Oh, 0 amp. Okay.
You can see display the red one.
Okay. I see.
Okay, this is a key to here.
That's only for 1 and 2, Mr. Pham.
Yeah, I supposed to change it to 3 or 4. Okay, let's see, next one. Okay, now this one I can 7, 8, 9. Okay, the other one I forgot to do it. So
You
we are 4.7. Number
skip
8.
5 and 6.
You skip 3 through 6.
You skip 5, 6. Go back one page.
Okay,
That's 1 and 2.
5, 6.
It's not synchronizing.
Your solutions answer says number 1 and number 2.
Let's see. Number 3,
Solution.
4. 1, 2 here. Okay.
Wait a second.
3 and 4. Okay. And 5 and 6. Okay, 5 and 6. 5 will be minus 0.7. 6 will be 6.2 milliamp. Okay, 7, 8, 9. 7 will be 4.7. 8 will be 12.87. 9 will be 1.88 milliamp. Okay, you get all the answers here?
Yes, sir.
Okay, go. 7, 8, 9. 10, 11. 10 will be 169.7. VP primary. That means they asking about primary right here. And the secondary,
Nắp nè. I guess I'm smelling coconut now.
Secondary will be 42, 42.
Okay,
Next,
makes sense.
12, 13. 12 will be 41, 73. 13 frequency will be 60 hertz. Same frequency.
good job, Mr. Pham.
Last one.
Yeah,
Hey,
next, that's the last one, Mr. Smith.
Could you please show again number 1?
That's number 1.
Thank
you. Okay. Anything else?
No more, sir.
Okay. We'll see you guys next time.
Thank you, sir.
Hopefully you guys can get better.
Thank
Thank you,
you.
Mr. Pham.
Yeah. I do the best to support you guys. You know, when you're doing the quiz, you can do it right away.
Once I get an NC cap, Mr. Pham, I'll be able to do it fast like you.
You're doing a good job.
Thank you.
Good job, Mr. Pham.
When
Hey,
you
Joseph, all we see is the top of your head.
Mr. Pham,
Thank you, sir.
Mr. Pham,
Yes, sir.
I got a question for you. On the dial, okay? You know, we have the Zenith dials number where it's going to be like 5-volt or 12-volt, whatever. But then when you look at the specs nowadays, they give you a VRRM. Is that equal to the Zenith dial number, the voltage?
No, I don't know. I not look into the data sheet.
Let's see if I could. You got time? I can share screen and then you can maybe tell me.
Okay.
Okay, hang on. Oh, hang on. I need to pull it up first. Give me 1 second, okay?
Yeah, anyone in the class, you know something else, you want to, for the people know, I can let you guys say it.
Okay, let me just.
We learn together.
All right, give me a second. Let me.
Got a quick question for Sam while he's looking for that. Is there something in the resources that could go into the Zener diodes a little more?
I would definitely recommend you can always go into you can always do the search you want to do is go into YouTube.
Okay.
And you can do search for say that you want to learn more about Zener diode, and they got very good explanation on Zener
Okay.
diodes and all diodes.
Yeah, I've been.
Hey, Sam, on top of that, hey, Sam, on top of that, if he do like diodes for dummies or something like that, usually it pops up real quick, those tutorials.
Hey, thanks a lot.
There you go. There's a recommendation from Mr. Smith. So go get diode for dummies.
I mean, really, they do. Really, they have it on.
Yes. Right.
No,
So
I have been going on YouTube just to try to keep up. So yeah.
Okay.
Yeah. Okay.
Can you see my screen?
Someone asked a question about the actual numbers, like what we're seeing now, 1N5711. There's a standards body that assigns these numbers. 1N refers to diodes, 2N refers to transistors. So every time somebody comes up with a new, say, diode design or Zener diode design, they go to this standards body called JDEC, and I forget it's JDEC. I'm not sure what it stands for anymore, but they assign numbers, and that diode becomes standardized. For example, when I was first starting out in engineering, like there was this universal transistor. It was the 2N2222, and you use it for everything, everywhere.
So anyway, Mr. Pham or Sam, so when we talk about the Zenith diodes voltage on the data sheet, would that be this number here, this VRRM of 74?
That's a V max, right?
Sorry,
Can you zoom in? Can you kind of, yeah, just go ahead and zoom in a little bit more so it's clear. Okay, look like a little bit. Okay, right there, it's good. Okay.
That's
You
what,
need to go up some for the absolute rate. There you go.
so is that the standard voltage?
Let me see. Let's see, that's the rating for it. Okay, so that's a peak reverse voltage. Yeah, you can say that's the Zener voltage.
Okay, that's all I need to know. Okay.
Yeah, because
Sorry, this is not a Zener diode. This is not a Zener diode.
yeah,
Oh
that,
yeah, this is Schottky.
It's a Schottky
different
diode, which is a
diode.
metal semiconductor junction as opposed to a PN junction.
Ah, okay.
And this VRRM is the maximum voltage that it can be, reverse voltage that it can be exposed to, without failure. If you
Okay.
exceed that, then the diode will fail.
Yeah, you're right, Richard. Thank you.
Hey, you know what? If you read that up in the upper left-hand corner real quick where it's got description that it tells you the whole thing about metal to silicon junction, diode featuring high breakdown, low turnover voltage, and ultra-fast switching.
Okay, so this one, you do it as a regular diode. Right? Hello?
Yeah, this is not a Zener diode.
Okay, but you just use it as a regular diode then.
Yeah, that's normal.
Okay, all right, thank you.
Okay, we'll see you next time.
All right, thank you.
Thank you.
Thank you, Mr. Pham.
Thank you.
Thank you.
Thank you.